Hello and welcome back to the Strange Water Podcast. Thank you for joining us for another awesome conversation. We've spent a lot of time on this show talking about zk cryptography. We've gone deep on implementation and have been far out with how zk is going to be the backbone of an automated Internet of Things world. And we've spent a lot of time thinking about the conceptual purpose of zk. In searching for this conceptual purpose, we keep coming back to the idea that zk is a technology that allows us to project computation across different computing environments. This is particularly important in the context of blockchains, which can be thought of as computing environments that sacrifice performance for credible neutrality and trustlessness. Before zk, only the most basic computation was possible in the extremely limited blockchain environment. But with zk, we can use high-performance modern computers and then send the answer and a proof into the blockchain environment. If the proof verifies, then we can treat the result like it was computed within the trustless blockchain environment itself. And so that's the basic idea of how zk interacts with blockchain and a glimpse at how it will forever transform how we use it. But the gap between that idea and an integrated, automated, distributed system is very wide. Fortunately, we have the perfect guest to help us see the future. Kartin Wong is the co-founder of HyperOracle, a company taking the very latest zk technology and actually building out the infrastructure that drastically changes what the world computer is capable of. Now, based on the name, of course you know that HyperOracle is capable of delivering prices and other data into a blockchain environment. But just wait until you hear about zkAutomation or zk machine learning, and you'll quickly see that HyperOracle is about so much more. It's about bringing modern computation, and with it, modern capabilities and modern adoption to the world computer. One more thing before we begin, please do not take financial advice from this or any podcast. Ethereum will change the world one day, but you can easily lose all of your money between now and then. All right, ladies and gentlemen, Kartin Wong. Kartin, thank you so much for joining us on the Strange Water Podcast.
Yeah, hi, nice to meet you, Red.
Of course. So before we get started talking about zk and about HyperOracle, I'm a big believer that the most important part of every conversation are the people in it. So with that being said, can you tell us a little bit about who you are, how you found crypto, and I guess once you found crypto, why did you not run away?
Yeah, so I'm Kartin, and I'm the founder of like HyperOracle, which is like a programmable zkOracle protocol. So basically, if you empower this on-chain oracle, will empower smart contract to perform more computation and have a accessibility for more data. So about more computation, we can enable smart contract to do statistic computation, AI inferencing, and uh, and like for data, we can have like internet data and on-chain historical data for smart contract. And we use ZKP to, like compress the data and computation and then get the result and the proof to the smart contract. So that's what we do. So, and I actually got into crypto quite long ago in high school, and I co-authored like one of the Python Bitcoin mining library with my high school teacher. And then we are kind of dumb back then. We don't think it's real money. So what we do actually, we didn't use the script. We test the script and got some Bitcoin. It was like 50 or 25 Bitcoin per block, like back then, 2011. But like all we do basically sell the script for 10 USD, and then that's like how we do. So our client got really rich, but like we are kind of like broke still. And then so after I got some money, I go to like US for school, and then I study astronomy and physics back to the college. And then after I graduate, I just go to Google and go become a software engineer and go to TikTok to become a tech lead on like the tech side for the privacy department. And then I come back to crypto because like obviously the bull market, and also like the TikTok always have a plan to cut the department of privacy preserve. And then because like they just spent bunch budget on the privacy team, but they find out American government no, actually they don't really care about that at the actually because like a political pick for them. So just cut the budget. No matter how good they do, it doesn't matter really. And like so I just like okay, then I should go to some like industry that actually care about this like cryptography technology and stuff. And then so I go back to crypto, and back then 2021, that's when I decided to come back to crypto. And then I check how many solution, architecture, and layer one, layer two, like bunch of architecture and solution. And then I find out there's like a rat market. I don't want to join the dogfight among the layer two, so an alternative layer one. So that I just like begin to think if there's so many layer one, layer two, all of them will need an Oracle, right? Like so I want to well position my business, and then like I just like see Oracle. It would be a good industry, and I begin to do research on Oracle, and then I find out like majority, I would say 99% Oracle, like basically it's a fork of Chainlink. So that I find out like it's like that's why they always like claim themselves a Chainlink killer, but they never is because they're just a fork, right? So there's no innovation there. Why you win the market? It no sense. And then I see like zk technology is getting more and more sophisticated. And now is the time that we can use zkP to do like approving on the Oracle industry. So that like was like I see there's two like uh, cycle is overlapping each other. One is the business cycle. There's like a blue ocean for Oracle, and then also the technology is facing a paradigm shifting, so that like we will be able to use the new technology to do Oracle. So these two factors together made me put down the decision that I have to do a company now. To start a new protocol. I mean, like not a company because the crypto industry is a protocol now. That to revolutionize the Oracle industry.
Yeah. So we'll talk about a lot about what you're building and like the opportunity that's so clearly ahead of us. But while we're still in your background, so you said that you were working at Google and TikTok, right? Were you working on cryptography?
Yeah, kinda. It's like trusted hardware. So basically, in Google, it was like it's like trusted hardware. Basically, you need to do like a formal verification and do like TEE stuff and CKP stuff for the hardware and for the cloud computation. That's like the job in Google. And later on, the TikTok is like it called trusted computed department. And then it's for the TikTok cloud. TikTok have like cloud, but they never public it. Just like another big tech company that have their own cloud department. Yeah, that's what I did.
I guess you've already a little bit answered this, but I would love if you could expand on this. I think for most of us who kind of came to cryptography organically, or at least through crypto, we have this magic moment that happened in the last 2 or 3 years where we've all realized that ZK, while it has application to privacy, is like not really about privacy. It's much more about like being able
Succinctness.
to, yeah, succinctness and being able to compress and then project computation in and out of blockchains. I guess my question for you is, while you're working on all of this stuff at Google and TikTok, is are these paradigms and these visions of what cryptography are for like really clear, and do you think that these big companies are kind of ahead of us on understanding how zk is
Not
gonna
really.
no, okay, okay.
Yeah, the Web 2 perspective for ZK, right? Like it's really interesting dynamic in like this Web 2 company. They want to do ZK and TE stuff. It actually because they want to do two things. One is like because normally in Google and TikTok they call it trusted compute. Why it called trusted compute is because like it's a cloud computation. You have a client. The client will worry about like let's say if your client is like the competitor of one of the Google's product, and then you worry about that if you use Google Cloud Platform to run your computation, Google will steal your stuff and mess up your computation. And so the Google Cloud Platform need to prove to the client that they're executing a computation privately. Even Google doesn't know what the heck is going on inside the computation. That's the first one to preserve the privacy for the computation job for their client. And because some of the client will be some bank, right? They have a multiple different bank, and you don't know if have Google invest on some bank and you would prefer another bank over another and steal some information for another bank, right? So you will want to Google to prove that like they are executing the computation fairly without like snooping your data and computation process. That's the first one, privacy. And the second one is that they want to they want to tell the user that like all their computation are safe and nobody can snoop, can backdoor their program database and stuff like that. Yeah, it's like another one is like for security. Like it's just like the two main purpose for doing like the zk cryptography TEE in Web2 company. But like from long times ago, why zk tech is like was being invented, right? It's because like in back to 1980, like there was like a time that like the computer was super slow in like some military devices, right? So like they will want that if you have like a commander center that can have a perform more complex compute and send a command to a certain super slow computer, and then they will can execute and decode the stuff like verify the information quickly. That's the original like purpose for doing zk, to like prove to a super slow machine that like you finish a super complex computation, right? For a commander center, you got a cluster of computer, you run all the computation, and now we decide to go to this place. And then like you need to send this information with the proof into like a super shitty devices that the soldier have in their own side. So to confirm that it's like not a fault message from the enemy and stuff like that. It's like you need to prove the super slow machine. But like because like but this situation kind of got weird because like later the computation the PC or like the private devices just developed so fast, this technology no longer really there's no super slow computer in the world for a while until the blockchain, right? The blockchain essentially is like a super slow computer, so that we can use the succinctness to complex compute and then have the result and the proof to the blockchain.
Yeah, I mean, there's something super interesting about how Moore's law really took a lot of like the hard, interesting problems that we were working on and just made them irrelevant when we thought forever. But it turns out that like all of that really cool, like I mean, the more you know about ZK, the more it literally is magic, and the more you're like hiding numbers behind curves and like doing all this crazy stuff, and it's like totally. I don't know if weird is the right word, but just interesting how we found ourselves like Moore's law took care of the computational differential problem, and then 30 years later, we decided to reintroduce it.
Yeah, exactly. And and like also in Web2 ZK, like you don't really need to care about the performance that much because like the verifier is not a blockchain. The verifier essentially is like another server, super beefy server. So you don't need to worry about the proof size. You don't need to worry about like how much the efficiency of the polynomial and stuff. You don't need to worry about that. So that's why in Web2 they doesn't really lean on the technology. It's like it doesn't really develop anything until crypto is like
Yeah, and I just recently had a conversation with someone about like kind of the more fuzzy thoughts around like ZK and security and like open source verifiability, right? And let's say for 99% of the applications that you and I use on a daily basis on our computers, like they're probably open source. We probably could go find the source code. We probably could download it. We probably could build it ourselves, and we could check it against the hash that the website put up there and make sure that everything's fine. But like, who does that?
nobody. MD5, whatever. It happened. Yeah. That's why like the supply chain attack is like a thing in the open source software. Like you can just like poison like some open source library, and then like all the library that rely on that library, they will be wrecked.
Yeah, yeah, and it just I think a question that like we all need to really wrestle with is like how much of this like decentralization permissionless stuff is like us really just like masturbating each other on like thematic things that we care about versus things that actually matter.
Yeah, yeah. I would say like like the ZKP today is like really efficient already compared with like 10 years ago. It's like it's not even the same era. So we can use, of course, use like this new tag to apply on morphing, not just Oracle, and also like bunch new kind of stuff like transaction formalification, a bunch technology can be applied on. Yeah.
Well, I think there's always a really important thing to talk about in technology where it's like getting 100x or 1000x efficiency improvements aren't just important for the technology, but they make the technology applicable to more
Fundamentally
things.
different.
Yeah, fundamentally different. Exactly. And so I think let's pause this part of the conversation. We'll return to it once we understand more about what HyperOracle is and does. But to suffice to say, it's like very clear that we've just in the last year or so hit the point where ZK has hit its first 1000x improvement and we can start to perceive applications, and we're still have at least one or two or three more 1000x improvements to come until it's like real technology. But with the background as it is now, and especially where it was when you were starting HyperOracle, can you talk a little bit about like what did you see and like what were the problems that you were seeing, and before you even got to the solution being I need to build this protocol, like what were the things there that needed solutions?
So before I built HyperOracle, like, and also I feel like smart contract really need something new and not an enterprise have a huge attack vector. So before HyperOracle, I think all the Oracle services is pretty much like fully centralized. Like, it's no way they're not centralized because the traditional Oracle mechanism that basically introduced by Chainlink is basically everybody just whoa to a smart contract, right? So like if you have 900 people vote for smart contract, the gas fee is unscalable. The gas fee would be like, per minute it would be a few $1,000 per year would be like $60 million, something like that. That's like basically it's basically it's like unscalable. So like which will make all the Oracle provider try to like make things aggregation happen in their own server, but when the hacker hacked their own server, aggregator server, it basically had every voting. So it's like, it's super dangerous to have that. It's like, what's the point of using that? Why not just have a server just directly report to a smart contract, right? So like, I see the problem is that like, even the D app still rely on a centralized server provider. So I was thinking about, can we put like Oracle system fully on chain, make it become a protocol, and then to make it safer, faster, and cheaper to use. And then so that's like the problem exists before HyperOracle, and now through like the most sophisticated like zk technology we have, and also the open source library we open source just recently called OPML, that will enable like any AI model and any on-chain historical data and internet data into the smart contract and do the computation inside the Oracle, but the Oracle is on chain because the Oracle trigger is on a smart contract and it's settled in a smart contract. It's like when you start a transaction from a UA account, it's like that kind of experience, and the whole network is fully decentralized. And then it's like no, we don't even want run our own node, and like so that's like let people have like the incentivized mechanism along with like the layer one or layer two, so that every time they run this node, they will just run the HyperOracle node together, so that like they would be able to perform more value to the smart contract.
So let's talk about like the actual construction here. So we have, can you actually just walk through all the pieces, starting with like what did you need to deploy on chain when actually let's just walk through the life cycle of like, let's say the most basic Oracle process is I want to know the price of ETH. Like how would I interact with HyperOracle?
Yeah, that is like super simple one. This is like a price fee Oracle usage. So basically you in Hyper Oracle, traditional Oracle, let me just use traditional Oracle as an example. Traditional Oracle, basically you just call the Oracle provider and then like I say I want this and then make it in your image so that like, right, so that I can have that in my contract. But in Hyper Oracle, it's different. The reason why we call them programmable is because like you just program it. You just in zk graph and just say, hey, I want this data from Binance. I want the token price of Ethereum from Binance, from Coinbase, called OKX. And then you just write it. You don't need to call us at all. And then like you just write it, and then with JavaScript, assembly script, super simple. And then you deploy this job, make this job become an NFT, and then put it in Ethereum. And then you put down a bounty for whoever execute this job for you on chain. On chain, they will be after they pass the verification, they will be able to have the reward. Let's say I put down like a zero point 0.1 ETH per 100 block. Whoever can provide me this data per 100 block, they will be rewarded 0.1 ETH. And that is something mechanism like this. And then you probably as like an operator, Oracle operator, you see this job on chain, and then you begin to execute the proving from the OKS, Binance, and Coinbase, and then provide this data with the proof and submit to the verifier smart contract. If it passed the verification, you will be rewarded. And you do it for 100 block, you will be rewarded like 0.1 ETH and stuff like that.
So the fundamental idea behind HyperOracle is that instead of this kind of the current dynamic where like we have our Oracle contract and that's great if the data that you want already is in it, and if not, you need to like hope you know
Code them,
somebody
yeah.
hope you know somebody important enough to get your data in. But what HyperOracle does is flip that paradigm on its head and say all HyperOracle is doing is providing a like smart contract that accepts basically requests with bounties, and then it's up to like the Hyper Oracle network to look at those requests. If any individual Hyper Oracle operator says like, "Oh, that's actually pretty interesting for me. I'm willing to do that," then they run it.
It's more like economy reason, right? Because if the cost for you to run it is like cheaper than way cheaper than your reward, most likely you run it. And also the whole process is on like the layer one and layer two. It's not there's nothing called Hyper Oracle network exists. It's like the whole thing happened on chain, the communication.
Got it. Got it. And I think there's like a couple interesting things under that, but like really what you're saying is that there's not a Hyper Oracle separate blockchain that also needs to be maintained in parallel to like the chains in which you're actually using the Oracle.
Yeah. You don't need a chain to do that. So like you start the Oracle core inside the whatever chain you want to settle the result. Let's say if you want to do on Polygon, just start the core on Polygon, the result be settled on Polygon. And if you want to do it on Ethereum, you start the core on Ethereum, and then the result is settled on Ethereum.
So I think let's like jump from a super simple thing like a price feed to something that's like super complex and interesting. So I saw a couple examples of I guess like hypothetical zk dhaps that you could build using HyperOracle. Could you just pick one of those, explain us to what it is, and then I kind of want to talk through like the specifics of how it works. So like the requester, are they actually writing out the lines of code that they want executed, or and then all the life cycle? So can you pick a what's an interesting application on HyperOracle?
Yeah, we got a lot of applications, but like most recent one is like something called zkAMM. It basically is like I see the potential of this application can change the whole DeFi dynamic because like as we know, AMM is one of the most important application in DeFi, right? So, but the problem for AMM is that like for such a long time, the market making efficiency for AMM is quite low. Let's say because like you need to S times Y equal to K, right? It's like straight line, right? It's not even like proactive market making. So every time you use DEX, you will need to pay for the alpha for arbitrage trader who is like try to balance the value between the token pair in Uniswap V2 and Uniswap V3. And so you will actually have the worst rate than when you trade in the DEX than when you trade in the centralized exchange. So people will prefer to use centralized exchange because they have proactive market making. You don't need to pay for the alpha for arbitrage trader in centralized exchange. And so the problem is that essentially the problem is because the market making efficiencies for traditional DEX is limited. The reason why it's limited is because traditional smart contract cannot perform complex computation in it, right? So now we have zkOracle. How we can resolve this problem? How about let's move the market making strategy and computation into the zkOracle. Now, the smart contract just need to have a verifier, and then the verifier will be able to verify the computation from the zkOracle. So let's say I can change the market making strategy in the zkOracle from S times Y equal to K into some like fancy AI model, We can make an AI model as a market maker, or we can just do a linear regression for market making, or the spread computation, stuff like that. And then no matter what way, you will make it way more efficient for the market making. And then that people will prefer to use DEX more than centralized exchange possibly in the future, because you have like a good market making. Yeah.
And I think like a way to visualize this for those of us who aren't like actually building this stuff is Uniswap versus Curve, right? Curve has a fancier, like more nuanced curve, right, of exchange. But the problem with that is it requires the EVM to do more computation, and be that
Yeah,
what
gas
that
fees
means.
higher. Yeah.
Exactly, right? And so I think what you're trying to describe by the zkAMM is you can jam pack it with 10 times as much computation to get even
Yeah,
more
but the gas
subtle
fees
than
still the
Curve.
same. Yeah,
So,
and then how it works.
yeah, how does it work?
Oh yeah, so basically how it works is that like you basically like put down a model of whatever the competition you want as a market maker as like zk graph and deploy it as an NFT into the blockchain. And your smart contract basically your DEX smart contract basically run along with the NFT smart contract. And then every time you want to have a computation call, let's say somebody want to swap in the current block high, and then I submit the a request, and then like zk Oracle compile because they see the bounty in the NFT, and then submit the result to the verifier to your smart contract, and your smart contract do the verification. If you pass the verification, and then it will execute the order. Basically, it's like that.
And this is going to be tough without charts to really get this down, but I want to visualize this. So the idea in this example is you have the zkAMM, and that's a pretty simple smart contract that's just holding the assets and has basically a pointer that says, like, hey, this is the NFT, which we all know an NFT is really just a smart contract. So the smart contract is going to have the code that it wants to have executed and the bounty that it's willing to pay. And so the zkAMM will say, hey, like, let's on every block, I want somebody to like this bounty is active.
Perform this computation. Yeah.
All you need to do to win this bounty is perform this computation. And then I guess like the magic of the ZK is that we can verify because we have the NFT smart contract and therefore the code, and we have the solution and the ZK proof provided by the hyperoracle operator. With those three pieces of information, we can ZK prove on chain that the computation was run, the result is valid, and because of that, we can release the bounty to the hyperoracle operator.
Exactly. Yeah.
Yeah, that's super cool and it's interesting. And I think like the one thing that I'm like a little bit curious about is like at least today, and we're all hoping for an Ethereum that fixes this, right? But at least today, like we have this problem of the fundamental difference between EOAs and smart contract accounts, and like what's cool about the way you just described this hyper oracle system is it's super modular, it's super flexible, you can build whatever you want, but it does sound like you're adding all these different points where external actors need to create external actions that maybe. So can you talk a little bit about when you're comparing hyper oracle construction versus a traditional Chainlink forked oracle? How do these systems compare in terms of like the amount of external actors that are required and the amount of EOA actions that are needed?
Yeah. So it's from three aspects mainly. The first one is like decentralization, right? Because like now like any Oracle provider, they no longer need to go through the aggregator services like Chainlink, Redstone, and this similar type of Oracle services. So they can just directly communicate with the smart contract because you no longer need the aggregator server anymore. So you don't need to go through the enterprise Oracle provider first and then aggregate the result into the smart contract. You can just directly send to smart contract. That's the first one to make it more decentralized, so everybody can participate and join. And second one is safer actually. The reason why it's safer because every computation have the proof. So even the Oracle node is hacked, right? Because like even you hack, so like your proof didn't match the result, you still cannot pass the verifier for the smart contract. So the worst case in here is not. In the worst case, like you just don't have data and or doesn't have the computation result, and your smart contract won't lose anything for it. and that's like the security part. And the third one is like the programmability. So you no longer, because like the operator, right? They just like download the NFT, basically check the NFT data, and then run the program, and then like according to the NFT, right? And then submit the result back to the smart contract. The whole process is like permissionless. So it's like I should phrase that as like permissionlessly programmable. It looks like nobody have used this term, like permissionlessly programmable. So that like the anyone can just like, if you want to use zkOracle to perform something for smart contract, you don't need to ask anyone to do it. So you can just write the program and deploy it, put down the reward, and people will do it for you. It's like the concept we propose. I call it like proof of Oracle work. It's like proof of Oracle work is just like you do the job, generate the proof, but it doesn't generate consensus between the node.
The thing that jumps out to me as like scary about permissionless programmability is just when you're running other people's code, your machine's at risk, right? And I
Oh
think
yeah, you are right.
yeah, so can you talk a little bit about like what, let's say I'm interested in being a hyper oracle operator, like what do I need to be worried about just basically running arbitrary code in exchange for, small crypto bounties?
Yeah, so like small crypto bounty, like you just need to compute the do a calculation between your cost and like your reward, right? If it's positive, you should do it. If it's negative, just don't do it. So we will provide a calculator, like because the same logic as a gas fee, right? So basically, if the reason why you don't need to worry about someone have like a Trojan or virus like deployed in a smart contract, because the gas fee for running that is quite really high. So like we have something like that to in case the cost computation is like guess computation is same thing. It's just like how many bytecode you're executing in the whole workflow. So you in case like people just write while true and then never end and then rack the computer of like the operator's machine. We will have like the that kind of analyzer for our node operator, so that we can dodge that kind of like filter out all the problem code from the zk graph. Yeah.
Got it. So sorry, let me repeat and tell me if I got this right. That your solution to this is the same solution that basically we have in blockchain or within the EVM, which is to simulate the transact or simulate the computation, like look out how much work that actually costs, and then provide that to the operator beforehand to allow them to make kind of a coherent decision. And then it becomes like, yeah, like things could change in that moment and like it is what it is. But like the idea is we just try to like front as much of the economics as possible and then let the actors decide.
Yeah. If like they see it as negative and also have like a kind of suspicious code, but they still run it, it's their own problem, right? You cannot really stop that. Yeah.
What about, do I need to worry about things like somebody putting in code into a hyper oracle bounty and then running that code and suddenly there's something malicious in there and they've gained root access to my machine?
Uh, yeah, that would be like a security problem we need to concern. To be honest, it's like a good question, really good question, because like we have think about this question for a while, and right now we don't really have like a perfect solution for it. But like hosting running the whole VM image inside isolated environment is like our suggestion, because like you never know what's going on inside. But if you just like create a virtual machine, even they got a root access, doesn't really matter.
So I guess my next question is like with that being said, like what kind of computing environment is available to people that are like creating hyper oracle bounties? Like are they writing Python code? Are they writing like what kind of code is it?
They just need to write assembly script. Assembly script basically is JavaScript that compile into Watson binary code. So just JavaScript is like same syntax with JavaScript. It's pretty simple. Every programmer knows it basically. So like yeah.
So you're basically saying if we simplify everything we've talked about down to you write your programs in JavaScript and then a hyper oracle like node will run it for you. That's you've essentially brought JavaScript to the blockchain.
Yeah, basically. But every like Ethereum developer know how to use assembly script anyway today, because they need to set up the sub graph node, right? When they use the graph for indexer for their own protocol, they will need to set up something like that. So I would say majority of like senior blockchain developers already know like how to set up this kind of thing. Yeah.
Got it. And so I think like for me, we can talk all day about how this enables and like gets us to the multi-chain future, which I think we all believe that the multi-chain future still has like Ethereum as the important chain, but and then all the L2s and things outside of that. I think if you have any like interesting insights or any ways that Hyper Oracle is going to solve that problem, I'd love to talk about it. But the other thing Hyper Oracle is like clearly here to solve is the bridge from the EVM into outside environments, whether that's the internet or real world assets or that kind of thing. So before we get to that, is there anything we should talk about in particular about what Hyper Oracle is really going to do to like supercharge the roll up centric roadmap?
Yeah, so I mean, like HyperOracle is free to use, right? So every roll up basically will just come with like a free organic Oracle services that thus they don't need to pay for any subscription fee, and then which also use their token as like a native gas metric. So I would say every roll up will like that, and they can empower them a lot. Yeah.
Mm-hmm. Yeah, cool. Yeah, and I think especially like through this bounty system, what's cool is that it enables anyone to have this functionality without like really freaking out about your token and like those kind of economic pieces. So big fan of the system you're building. So let's talk about the again like what types of things Hyper Oracle allows in regards to connecting the blockchain to the real world. So like I think the big thing is like you're adding an internet connection to the world computer, like you are giving connectivity. So can you talk a little bit about either the visions that you guys are having at Hyper Oracle or some of the projects that are already starting to be built on like how this technology will like kind of bring us out of casino land and into like really supporting the financial system?
Yeah, so there's a many way, right? So I would definitely say like AI will be the game-changing like technology here because like when people talk about AI times crypto, it's like a kind of no use case and like kind of bullshit. But like in our development and when I think about use case, we find out many things that might actually bring us like massive adoption, meaningful application. Because like right now, um, just like bringing more data into a smart contract is not enough because the you need like strong computation. You need a CPU, strong CPU to process this amount of the data, right? But like if your computation ability is quite low, even you have all the data in the world, it doesn't it's just meaningless for you. And like so we also have the computation part in HyperOracle that will empower smart contract to do more computation or like help them to digest all this data before they receive it. And then so that we can see many interesting application like AI GCFT. Basically, that will make the whole creator economy like move it to blockchain, so that every inference word for the AI GC model will be able to become a financial asset. Because like in let's say 5 to 6 years from now, majority of the art in the world will be produced by AI, right? Like that's just really clear trend. And then but like before when we develop NFT technology, like obviously nobody really expect that will happen that quick. So NFT is more about like a creator economy, and the artist got the loyalty fee from like the future trading and all kind of stuff, right? We can actually parallelly migrate the whole business model from the NFT to the AI. So the AI itself become an NFT, and then all the inferencing or all the artwork that created by the AI model will be also the sub NFT for that AI NFT model. And this kind of like a new innovation will actually help to boom up the technology for open source AI. Because right now, like open source AI does not really have like a sustainable way for their business model. The only way for majority AI company to make money become profitable is that they close source for their model and then provide the API, right, and charge $20 a month, something like that. And it's like basically blocking the knowledge got like propagation, right? The knowledge propagation. So we, but by deploying AI GCNT, they open source the AI model, but still make huge amount of the profit through the AI model. So it can help the AI industry to evolve faster and quicker and more open to the world. That's like the first one. And then like the second one is that like um the lending protocol, let's say, you can basically like if somebody put down collateral through like some organization, the bank, right? I put down my house as collateral in the bank and then want to lend something in the on chain. I want to get some USDC because I put down the collateral. And then also the M model can analyze to help to do the fraud detection, like to see is this collateral is real. It's like a credit card, right? It's like so you do the fraud detection so that people on chain will be able to lend the stuff to another people easier to increase the capital efficiency for the world. So that's the changing I'm seeing because like for massive adoption for blockchain technology, you need to use blockchain to do more things, right? It's the same logic that like why smartphone and iPhone is like dominating the world now. You have more smartphone than people. That's because like you can use phone to do a lot of stuff, right? And then the reason why you can use phone to do a lot of stuff is because like your phone have a stronger and stronger CPU and GPU every year. So that you'll be able to have it to do many applications that was impossible before. And so same as smart contract, if you want to use smart contract for more stuff, you will need to like have a smart contract to perform stronger computation and more data access.
Man, you said a lot of like really interesting stuff there. I think like first
Yeah.
and foremost, I came to crypto like through the lens of finance, and I came here into DeFi first, and like for my first like I joined in 2021, and for my first let's say year here, I thought like the point of all of this was a better financial system, like we're going to replace
Yeah.
everything. And like just to cut to the chase, like I found zk, and like that's when I realized that this really is the story about distributed computing and not about finance. And if anything, I think like while all the finance talk and the money talk has been great for like bringing people like me in, I think it like really clouds what we're doing
Yeah.
here. And so, my big insight was we all can kind of recognize that NFTs were this crazy fad that went from nothing to like billions of dollars and then like
Yeah.
came back down, and maybe Bored Apes or CryptoPunks will be worth money like that again, but we all know that that's not coming back. And that's okay though, right? Because like this
It's like
trend.
different cycle have different like asset
Exactly.
class
And
that
like what did we take from it? We took these like core primitives like NFTs, like ERC. Well, there's a few of them, right? But like we took these core primitives and like exactly like you're saying in just the basic structure of HyperOracle, like we're putting them to use. I just love that like these bounties and the code that you're running are NFTs. Like that's exactly how I think that what we took away from the NFT boom really matters without NFTs actually mattering. And so, like, I so am on board with you there, and I know I am so confident that crypto and AI are part of the same story. Like, crypto is about scarcity and it's about provability and identity and just slowing things down, while AI is about speeding things up and about like abundance and creativity and chaos. And like I know that those two
I think
come
that both is
together.
like a complementary like relationship.
Yeah, for
Yeah.
sure. And I think on this show we've talked to Jason Morton from Ezekiel, and we've talked to Dan Shore from Modulus Labs. Like, we've had a couple conversations about AI and ZK and how they come together. And again, like I don't really know yet, but like I can totally imagine that like maybe the point of blockchain is just to give the AI that we're building identity and like elevate it to the level where it can actually change things in the world. And like it's again these conversations and exactly what you described that like help me start to like really piece together like how we get there.
Yeah, how we get there? It's fast. Like we already enable any AI model on Ethereum and any L2, like any, literally any. And then it's just like right now all the piece of the technology is like is there. You just like need somebody to assemble them together, and we are assembling it. So I think next year like they're gonna have a boom of like AI application on chain, and then we will see.
Okay, man. I let you get to the like big brain part a little too early, but I want to like take us back to hyper oracle and how it actually works. So like one of the things that I'm thinking about like in this AI empowered world where like at the end of the day we actually do need people to be running the like plugging in these computers and like servicing them and like downloading the software and like opting into the system. So like I said, huge fan of the bounty system and like how that makes much more sense than like the direct like token based system. But how can you talk through like how you are thinking about bringing hyper oracle operators to the table and like building a community of people that like want to participate in this kind of work?
Yeah, I think it's just like we need to have a really good tooling for the operator so that they can avoid to being attacked and they will avoid the malicious software and stuff like that. And then beside that, um, I think the most important is that like we made the whole mechanism smoother and like people will like easier to participate. Like you can just have a phone and then review like what job is happening on chain, and then if you even your phone can do a proof, right? And then like you can contribute a computation resource on your phone and make earn some money through your phone. So everybody be able to like contribute to the network and then like work to assemble the world computer.
Yeah, man. Yeah, again, I love the world computer metaphor and like what you're talking about really does bring it to life a little bit more. Do you have any concerns both on just like the realities of building like a community, but just even on a theoretical level? Do you have any concerns about centralization at the hyper oracle layer? Like imagine a world in which T-Mobile is the only person willing to do this. Like, is that a problem?
Good question. It's not a problem at all because like HyperOracle is fully open source and like everybody can download the image and run it without our permission at all. It's HyperOracle is like it's not a blockchain, but it's like a protocol. It's like a way how you communicate with blockchain smart contract. So that like this decentralization definitely is not an option at all for us. It's like it's basically in the whole design. There's no element that is like centralized because like when you talk about centralization, it's like talking about permission, a whitelisted operation, right? Only certain people can do certain thing, right? But in the whole protocol design, everybody can deploy any computation, including maybe like dangerous or suspicious computation into mainly as NFT, and then like they can another people, anyone in the world, will be able to download any uh, zk graph NFT to their own computer and then run the computation and submit to any smart contract that they want to submit to. We don't really have the control for the whole process. It's fully like on chain. And so like that's why it's kind of like on chain Oracle. It's not enterprise Oracle.
Do you? So I guess with all things zk and all things I guess blockchain. At the end of the day, like you're relying super heavily on the cryptography. And so, can you talk a little bit about the choices that you needed to make when you were designing this system? And like, I'm always interested in talking to builders about what it's like implementing zk when zk is changing so fast.
Yeah, that's true. ZK does change really fast, really fast. I remember when I started to do the Hyper Oracle, there was like a paper called Hyper Plonk, and that was like a sum check protocol for the ZK protocol. And then it was like the thing at that time. And after 6 months, you got folding, and then after another 6 months, you got like cyclic folding and all kind of like new tech that's there. But you know what? Like one thing never change is like the KGG plonk is always there, like from Zcash. So that's why we the first primary library we use to construct the hyperoracle is actually the Halo 2 library, which is like provided by Ethereum Foundation. It's like completely public good, no commercial license. You can just do whatever you like with it. And then that's like the magic, and like that's like why open source software always gets more success, because like it just people can do it without any concern. Even probably they slower or even like perform it's not as well as another, but like because it's like public good, so you're just willing to even take the risk that is lower than another library but still use it. So but in the basically we just take Halo 2 from Ethereum Foundation and add our own modification with Definite Lab to make it like faster and more reliable and more suitable for our use case. So basically, we have like a Halo 2 version called Halo 2 Hybrid, which we develop, and then it's like have like some feature we need when another project might not need, and that's what we do. And it's also open source; many people can use it. And also, I would like to want to try another library called Plonky. It's basically developed by Polygon team, and then Plonky have like it's a hash based scheme. It's different with like a Halo 2 KGG, is like a KGG based scheme, and then but like the price for it is like you got bigger proof, but your proving time is way faster, and we have still working on the experiment on like try to have like a faster proving scheme and to make the whole zk Oracle system faster. Although right now our benchmark is quite good, it's just like 5 to 7 seconds to do the proof for the zk Oracle, which already shorter than the layer 1 block time, which is 12 seconds. But like for many layer 2, it's still not fast enough because for layer 2, right, the block time is like 2 seconds. So you wouldn't want it faster. So we still working on like different experiment to see how to make it even shorter. But right now our benchmark, I'm already really happy for it because like it's enough for us at least deploy on the mainnet for Ethereum.
So I want to get to latency in a second, but while we're just still on implementing zk and zk being an extremely fast changing technology, I think the message that you were trying to get across was that, like, yes, while things are changing, the it sounds like because the way that you're using zk is all you need to do on chain is the verification, and maybe you might need to do some smart contract upgrades over time if you like other proving systems, but it sounds like you're able to build this in a way where all of like the infrastructure kind of works regardless of the proving system, and then you can kind of like modularly swap in and out like whatever is the most performant, like the best possible thing at the time.
Yeah, yeah. So basically, we try to make the system more modular, modular, right? Because like so that because technology is always improving and changing, you don't know. Probably tomorrow you have like a new scheme that is like just outperform everyone like 10,000% faster, and then you just have to use it, but you don't want to redo everything, right? So like you better to decouple every code front end and back end together, and then make the decoupling really good. That essentially modular means like decouple every component in the code. Yeah.
So you brought up latency, and I wanted to talk about that. And so I think like your first answer is really answers the big question, right? Which is like how fast can we do a turnaround on a hyper oracle request, and like how does that interact with block times? And like totally hear you that if today we can beat mainnet, then we're fine and things are only going to get better from here. But I guess taking a step back and just looking at the big picture of the entire construction and the ecosystem that we're trying to build, something that I've noticed as like when we talk about zk, like we really like power through all of like the nitty gritty, which is like round the amount of round trips needed, the amount of just like overhead needed in verifications when that wasn't happening before. Like I'm wondering, do you worry that like the constructions that we're building are so because they're decentralized and have so many different components that we're always going to have trouble competing with like just using AWS? And then if so, like what does that mean about the systems that we're building?
Yeah, using AWS is fine in my opinion, like because it's fast and reliable machine, right? But like we always need to care about like the ASIC mechanism, right? We need to worry about like for decided protocol, you need to think about like what if AWS do not work all of a sudden or just become like some evil company, just ban everyone. Like so we as a protocol designer, you need to like it's just like Bitcoin, right? It's fine that every miner in Bitcoin is using AWS, completely fine, but we just need to think about the migration problem. What if like Bitcoin is like the AWS is no longer function or they just ban all the Bitcoin miner? What will happen? what will happen is that like you just need like the difficulty of like Bitcoin mining all of a sudden from 6-0 drop down to 2-0. And then any laptop computer will be able to run the Bitcoin node and then just mine Bitcoin out of it. So like that's like a migration problem essentially. So in HyperOracle, we have the same concern. Like, what if all the node operators is AWS and all of them just like not doesn't exist anymore? How to handle the migration problem? Actually, have a plan B for it. So basically, like because the bounty is still there, right? So like actually, it's easier to get the bounty because if every AWS machine is running, which means like you always have the competition. Whoever got the bounty first, who will be able to settle the reward for their computation, right? For their wallet, and then but if you don't have competition, which means like no matter how fast or how slow your computer is, you just run the job, you still got the reward for it. So like the migration is like a click, is like a second. Once the AWS is not functioning, all like a hungry like little computer will be able to go jump into it and like do the computation for it. It's like similar computation process of POW. The migration process could be quite similar.
So I think what you said is what's important in crypto and distributed computing is not necessarily to worry about like, okay, what does the system look like in good times? It's like, what do the failure scenarios look like, and do we have a clean glide path to get there?
Yeah, because like that's the secret spice that why Bitcoin is still running for 10 year, more than 10 year,
Mm-hmm.
right? Like a long time. And then like never have a problem at 15 year. And then like it doesn't have problem even once because
Mm-hmm.
like the migration designed really well. So like
Mm-hmm.
once the operator no longer operated, like
Mm-hmm.
the another people can just operate it with lower
Mm-hmm.
price, but still got the same reward. So like
Mm-hmm.
it's economy designed to make it migrate easily. Yeah, we need to think
Yeah.
about the exit plan when talking about centralized decentralized problem with AWS. Yeah.
Yeah, and I'm curious what you think about what I'm about to say. Another thing I'm starting to see a lot of, to the point that I think it might solve like the latency and the round trip issue, is starting with like the eigenlayer moment and then just watching everything that's come from that. It's starting to
They
feel
rise
more
so
and
quick.
yeah, it's starting to feel more and more like all of the computers that are running all of these services are going to be one computer, and they're going to be the Ethereum node. Or put a different way, the Ethereum stakers have computers that are much more powerful than running an Ethereum node, and they're going to use that space to be running everything from HyperOracle to EigenDA to like even like you know Polygon zkEVM
It
sequencers.
makes sense. It makes sense. Yeah.
Mm-hmm.
Actually, it's a really good design. Restaking mechanism is one of the best. Like I would call it a DeFi design in the space because it actually have a utility, and actually can have like a actual usage to pay for the yield, right? Like it's a really good design to be honest. But like what I my take for that is like I actually have a dual analyze like the node on Ethereum. Like, actually, majority of the Ethereum node is like quite weak. Like they don't even have like GPU with it. So which means like when in this restaking mechanism go into like AI and related stuff, most like a restaking node won't be able to perform anything. And if you can perform like a complex computation already, you won't able. Normally they don't care to be like a ETH node because the reward is not that high. Because the reward for ETH node is not based on how strong your machine is. It's based on how many ETH you stake in, right? So like you don't really want to do it just with a super beefy computer to become ETH node. So majority of the Ethereum node is quite like weak node. You probably have a CPU, probably have like 30 or 40% space left over. But what you can do with it, like probably some simple computation, like so in our condition, you definitely cannot use this kind of node to do zkP or AI computation, right? So that's why so far we never really used any restaking in HyperOracle because like it just because the node majority of Ethereum node is not capable to do it at the moment. And the point for Ethereum, right? The point for Ethereum to change from POW to POS is that low down the barrier to operate a ETH node so that more people can participate, more decentralized. That's the point for have a Ethereum 2.0, right? So like, I don't expect like this will work on zk Oracle and AI stuff.
Yeah, I think that's a fair point. I think, there's people like me. I run a node in my fiance's closet, and you're right, doesn't have a GPU. Like I spent like $1,000 on it 2 years ago.
Yeah,
So
it's like a BlackBerry
it's
Pi, right?
no, yeah, I mean it's fine. It's like an Intel NUC. Like, yeah, it probably has like 50% of capacity left to run stuff, and that's definitely not enough for AI, but it's probably enough to run the calculations for zkAMM, right? And so maybe
Probably that's a good point. That's a good point. Yeah, it might be, and like also like that's why eigenlayers have value there because like they basically utilize the empty space that in like the Ethereum node.
well, and then there's like operators like T-Mobile or I mean, there's so many of them that like are
Yeah,
huge and actually have extra compute power.
yeah,
I think Eigenlayer is amazing of because of like the amount of conversation and energy it's put into ZK, and I just love that everyone is talking about what they're going to build. I was like super into the idea, and then when they launched and it was a like they accepted all these liquid restaking tokens, and it's
yeah,
essentially the protocol is the idea is like you don't need to issue shitcoins anymore. Come give us
yeah.
good quality collaterals to farm shitcoins, and
Yeah,
then not only
basically.
now it's all like so you're hundreds of millions of dollars of liquid staking tokens, which is basically delegated proof of stake now. So the node operators, if they screw up any of the restaking services, it's just like some rando depositor who is going to suffer. Like the whole thing
Yeah,
has like
yeah,
a little bit fallen
yeah.
apart for me.
Yeah, it's like conflict. Actually, mistaking mechanism is kind of conflict with like the POS consensus because it's just like make it not secure anymore. But like it's still so far so good. But I don't know what's
Well,
will
so far
this
so good.
direction go to.
All it is
So
is a
far so
deposit
good.
contract.
Yeah, exactly. And like yeah, I think the Vitalik have a paper talk about it.
No, so I love how much energy it's brought into the space, and I love how many people have started building really interesting things specifically so that they could be on Eigenlayer. But
It's like an 80 Eigenlayer project, right? It's like a bunch. I see Eigenlayer like a new partnership every day. It's like
yeah. All right, man. We've been going for an hour. I could keep talking all day, but I can see it's dark there, so I will wrap this up. But before I let you go, can you please just let the audience know where they can find you, where they can find Hyper Oracle, and if they got excited about hearing about all this stuff, like where can they learn more and where can they get involved?
yeah, you can definitely go to our GitHub. Just go to our website, hyperoracle.io. Click the GitHub button. You go to our GitHub. We have a bunch like really good open source software to for everybody developer as a study material, or you just want to use it to build your smart contract. And also, you can if you go to ai.hyperoracle.io, you'll be able to see that like in the first time in history that we'll be able to perform large model in Ethereum smart contract. And also, right now we support Llama 2, ChatGPT 2, and Stable Diffusion. You can try it all out there. And you can also have me in Twitter, like X now, which my handle is like a 0x Kartin. And then I normally in the Bay Area. I also hang out with my friend in Stanford and Blue Bottle Coffee in Palo Alto all the time. So if you guys see me, you can say hi and have heard about this broadcast. And then yeah,
Awesome, man. Well, I was a Cardinal too. I graduated 2013 and studied computer science. But anyway,
great.
Carton, man, this is incredible. Right now there's so much going on in ZK, and really, essentially, what that means is there's a bunch of people building ZK primitives and just saying like, we're building, tools to abstract away ZK so developers can focus on applications. And it's pretty rare that we talk to someone who's actually using ZK to develop something useful. So, man,
Thank
I'm just
you.
so energized about Hyper Oracle and about like the world that you're enabling. And it's not often that you can start to see the future. And like this conversation is one of those moments. So, thank you, my friend. Really
Yeah, I
appreciate it.
appreciate it. Appreciate the time.